So this lesson is going to focus on finding the domain of composed functions. Okay, so here's how we have to do this. Because a function is going into a function, okay, it's going to be a little more complicated than just look at f and look at g. There is no f of x. It's f of g of x. So the g of x function goes into the f function. Okay, so here's the steps. Okay, number one, you have to find the domain of the, I'm going to put quotes here, the little function. The little function. Okay, so for this example, the little function is g of x going into the bigger function f of x. But it's not always the case that it's written like this. So you take a look at the little guy and we'll find his domain. Okay, that makes sense. Now number two, okay, the little function, whoever's inside, the little function must obey the big function. Put quotes on there too. The big function. Okay, that sounds kind of weird, but the little function is going into the big function. So if f says I don't want negatives, then g of x must obey that. G of x can't give f any negatives. And then the third thing that we're going to do is we're going to state the more restrictive one. We'll state the more restrictive one, okay? We have to do this three-step process since g of x is going into f. You can't just look at f of x and g of x separately because they go into each other, okay? So take a look at this right here. It doesn't say that we have to actually compose this. It just wants us to find the domain for f of g of x. And I really like to write it as f of g of x in this form so that I can tell who the little one is and who the big one is. Okay, so here's what we're going to do. Here's the steps. Okay, it says, number one, find the domain of the little guy. So let's take a look at g. G will allow all real numbers. Okay, that's good. Now step two, here's the tricky part. The g function goes into f. And so g has to make sure he obeys that. Okay, g, get ready. What does f say? The domain for f? Oh, there's no restrictions here. F will allow all reals. So no matter what value g is, I think he's going to be okay. Okay, so step two is all reals. This is an easy problem. Reals plus reals. Okay, so overall, the overall domain is going to be all reals. Okay, but we did the process the right way. We're going to take a look at some that are a little juicier now. Okay, so take a look at this one. I see f and he has some restrictions. Okay, so now we're going to get to some good stuff. Let's go ahead and write down the domain underneath these guys. So for f, x's would have to be greater than or equal to -2. But g, there's no restrictions there, will allow all reals. Okay, so let's follow the process. To find the domain, okay, what's step one? You state the domain of the little guy. So what's the domain for g? It's right there, all reals. Now, step two, okay, the g function has to go into f. Does f have any restrictions? F says you have to be more than or equal to -2. So g, you have to listen to that since you're the input for f. So here's what we're going to do. We're going to write down the g function. G, where are you? 4x plus 1. Okay, so get over here, g. G has to obey f. F says you have to be more than -2. So g has to be greater than or equal to -2. So here's the g of x function. Okay, and here's him obeying what the f of x says. So when you do this, you're going to get an equation or an inequality that has to be solved. So I'm going to subtract 1 from both sides and divide both sides by 4, and I have a new restriction. Okay. And then what we do is we put both of them together. So the overall domain is, I'm not going to say all reals, because he wants numbers more than or equal to -3/4. So who's more restrictive? X is greater than or equal to -3/4. And we don't say all reals when we say the inequalities. Okay? So step 1 is kind of like the old stuff. You just state the domain for the little guy. But the second step, you're going to have an equation to solve or an inequality to solve. Let's try some more. F of x equals the rational expression 1 over x plus 2. So I know that f has a restriction. Okay, he says x's cannot equal -2. And when I say x's, that means like the inputs. And g of x says your inputs cannot equal 1. Okay, so that's domain work from earlier in the chapter. So what's the domain for f of g of x? I like to write the nested form. So step 1, does g of x have any restrictions? Yep, g says x cannot equal 1. Okay. So step 1, what's the domain of the little guy? Now step 2, in this case, g of x is the little guy. G of x must obey f because g of x is going into f. So he has to obey the domain restriction. So I need to write down g. Where's g? Here he is. Let's write down the equation for g. G must obey f. What does f say? Your inputs cannot equal -2. And since g is the input, he cannot equal -2. How am I going to solve something like this? All right, we'll put a 1 under there. Say 2 words. Cross multiply. So you write your equal sign, and you cross one way, get a 4. Cross this other way. Okay, make sure you distribute to the quantity. -2x plus 2. I'm going to go ahead and solve this. -4, that's going to make -2. X's cannot equal -1. Okay, now I have to put my 2 steps together to make my overall domain. So the overall domain is all rails except x cannot equal plus or minus 1. Plus or minus 1. Now, do I state -2? No, you don't add that to the domain restriction. X's not equaling -2 doesn't really happen. X's never go into f. X's go into g, and the g of x function goes into f. So you have to follow the 3-step process. Step 1, step 2 shows me work, and then you put them together. Okay, let's do the same problem the other way and see what we get. Now it wants us to do g of f of x. Okay, so step 1. What's the domain for f? X's cannot equal -2. Okay, step 2 is the harder step. The f function goes into g. F is the little one. So f of x must obey g. So let's write the equation down for f. The equation for f is 1 over x plus 2. So that's the function f that would go into g. And g says do not equal 1. Inputs cannot equal 1. So this input cannot equal 1 because that's the rules of g. Let's go ahead and cross multiply again. 1 equals x plus 2. Oh, not equal, sorry. X's cannot equal -1. Okay, so we'll go ahead and put these 2 together. So the overall domain for g of f of x is all rails except x's cannot equal -1 or -2. So is the answer the same for f of g of x or g of f of x? No, the answers are totally different. Okay, you have to follow the two-step process there. All right, let's do some more. I have f and I have g. Let's go ahead and write down their domains. So the f function has no restrictions. He's just going to be all reals. And then the g function, the expression would be greater than or equal to 0. So all inputs have to be more than or equal to 2. Okay, when we say x, we mean inputs. So let's find the domain. Oh, hang on. It says find f of g of x. All right, so I actually have to do a composing problem here. F of g of x. Okay, so we're going to go ahead and write f of, and instead of the letters g of x, what's the g function? Square root of x minus 2. Okay, then we'll go ahead and put this equation into the f equation. Where's f? F says take your input, square it, and add 4. Okay, ready? We're going to do that. F says take your input and square it. Maybe I'll just kind of get ready with some parentheses. Input, square it, and add a 4? No problem. My input is radical x minus 2. So the nice thing here is the squared power cancels with the square root. And f of g of x is equal to x minus 2 plus 4 plus 2. Okay, so it says compose, and I did it. Now, looking at this answer, I would think, oh, all reals. But that's not how you do the process. Okay, so we have to make sure that we do the domain the right way. So for f of g of x, step 1 would say state the domain of the little guy. So we have to say x's are greater than or equal to 2. And then for step 2, g of x must obey f. So let's write the g of x equation. The radical x minus 2 must obey f. Must obey f. F says, I'll take all reals. Well, that's easy. Okay, f will accept all reals. Of course, he'll accept the square root of numbers. That's not a problem at all. So when we put these two together, the overall domain from step 1 and step 2, we're going to state the one that's more restrictive. X's are greater than or equal to 2. Okay, they also wanted me to do the reverse of this problem. Find, okay, so this says find g of f of x, okay, and state its domain. So first let's compose it. I have to do g of f. The f function is x squared plus 4. Now, what does g say? Sometimes I like to say it in English 3 times before I do it. G says, take a big square root, your input minus 2. A big square root, then your input minus 2. Okay, so that's what I'm going to do. Big square root. I have to put my input, and then it says minus 2. Okay, so we're going to have the square root of x plus 2. Can that simplify? No, that can't simplify. That's going to stay just like that. So this is g of f of x. And now we're going to find his domain. Okay, so the domain for for g of f of x, step 1. What's the domain of the little guy? All reals. And then step 2, the little guy, which is f, must obey g. Okay, you don't have to write this step anymore. We're just kind of getting used to what the rules are, so that's why I'm writing it in the notes. I'm going to write the f function must obey g. G says you have to be more than or equal to a 2. Okay, so x squared is greater than or equal to negative 2. I know I'm not allowed to square root. What if I said x squared plus 2? X squared has to be more than negative 2. Do you guys know what happens when you square positives? Do you think they're going to be more than negative 2? Yeah, what if I put negatives in and I square them? Are they going to be more than negative 2? What about 0? Is 0 squared more than negative 2? Yeah, I think all numbers, when you square them, are more than a negative. So this is actually telling us all reals. So let's put it together. The combination of reals plus reals makes all reals, which is weird when you look at an answer like this, okay? But makes sense for the steps. All right, we got one more. Find f of g of x and state its domain. Okay, so first I'm going to say here f of x does not want your input to be 0, and g says be more than or equal to negative 5. Okay, so first we're going to do f of g of x, which is f of, what's the g function? Square root of x plus 5. Now what does f say? F says 1 over your input. 1 over the input. And the input is radical x plus 5. I know we're not supposed to leave the radical down there, so I think what I'll do is multiply top and bottom by the square root of x plus 5, and that's called rationalizing. So we've got the square root of x plus 5 divided by the quantity x plus 5. I think what I'll do, well, let's see. We'll see how crazy the problems get, but maybe I'll accept both answers here because we're in the composing chapter. If you compose it, I'll be happy. All right, what's the domain? Okay, step 1. What's the domain of the little guy? G of x. He says x is more than or equal to negative 5. Now, step 2. The g of x must obey the f, since g of x goes into f. So what's the g function? Square root of x plus 5, and f says do not equal 0. Okay, how do you clear a square root sign? You put parentheses, you square the entire left, you square the entire right, and we get x plus 5 cannot equal 0. X cannot equal a negative 5. So how are we going to combine this for my overall domain? He says be more than or equal to negative 5, but this part says don't equal negative 5. So I guess I can't equal you negative 5. I'm going to say greater than negative 5. Okay? So the question here is, can you find the domain of a composed function, okay, using the two-step process? I sure hope so, and we'll practice tomorrow. Thanks, guys.